Hey there, AP Chem scholars. That was really goofy. I'm going to leave it anyway. So 4.1, Intro to Chemical Reactions. Really short idea here. The emphasis is not just on chemical reactions, but understanding the difference between a chemical change and a physical change. Okay? When we talk about chemical reactions, that means there is a chemical change going on. All right, so again, what is the chemical change? A chemical change on a macroscopic level means that we're forming new substances with new sets of properties. Okay, I say on a macroscopic because we tend to look for certain signs when we talk about a chemical change or a chemical reaction, right? We talk about the idea if temperature is changing, is heat going in or coming out? Okay, that in and of itself may not mean it is a chemical reaction, but it could mean, okay, because when bonds change, there's going to be a temperature change, okay? So it is a possible sign, okay? Does the color change? Is there a precipitate forming? Okay. Are gases being produced? Okay. So these are the questions that we have to ask ourselves to start saying if we think something is that we're observing is a chemical or physical change. But understand the huge difference between a phase change, which is a physical change, and a bond change or a chemical change. Okay? When we talk about water, ice becoming water, let me grab my ice. When we talk about ice becoming water, okay, when I start pulling this apart, okay, and taking the ice and breaking intermolecular forces, I still have water. I have not changed the identity of the substance. I haven't changed the bonds. Bonds are what are identifying the substance, okay? This is still H2O. So even though I melted this from a solid to a liquid, it's still H2O. The bonds have not changed, okay? Only intermolecular forces have changed. That's a huge, huge difference. And it comes up on the AP all the time. They're going to ask you if you boil something, okay, what's going on? And some people are going to say bonds are being broken. No. When it's boiling, it's going from the liquid phase, where we have these water molecules kind of just all together, but a little fluid. And then it's, moving off in the gas phase, all moving off on their own, flying all over the place. Okay, that's when it's boiling. Okay, they're still water molecules. Okay, but now they're just free because they don't have those intermolecular forces holding them in place in that liquid state. Okay, so you have to understand the difference then between bonds and intermolecular forces. That is going to come up a lot. If they show you structures, I mean, obviously when we talk about a chemical reaction, like, for example, methane plus oxygen making carbon dioxide and water, okay? Obviously, we see that we're getting new substances, so there's got to be, bonds being broken and bonds being made. And we could even draw out the Lewis structures and talk about the fact that in order to do this, I really should balance this, I guess, technically. But that'll be the next thing we're going to talk about. Anyway, okay, we can see that in order to go from this to this, there's a whole bunch of bonds that have to be broken. All of these CH bonds, the OO double bonds. Then we have to make OC double bonds. and a bunch of OH, single bonds. So there's all kinds of bonds being broken and made. That's really what defines a chemical process. All of this stuff is just ways that we try to use to see that it might be a chemical change. Okay? Again, giving off a gas. If I boil water, a gas is coming off. Okay? Usually with a gas, we're talking more along the lines of like a smoke or something like that. But even then, some gases are just colored, and you might be mistaking the boiling process for a chemical reaction. So it's got to be generally we want to see multiple things if we're going to do it by eye, and we're going to judge whether it's a chemical or physical change. When we talk about a chemical reaction, we talk about chemical equations, and we talk about the law of conservation of matter. The idea that we cannot create or destroy matter, and that's why we have to balance these equations. We talk about our reactants forming our products. And the fact that the reactants are the ones that have to do the bond breaking, and the products are the ones that have to do the bond making. So that is the complex process. We also have to understand that really, even though we show it like this, there's steps going on. You can't have just a methane molecule bump into two oxygen molecules and bam, all this just happens. Okay? There really is a series of steps that are going to happen between here and here. We're just looking at the overall, the start and the end. Eventually, we'll talk about what goes on in the middle. All right, so phases are often included on the AP exam. You don't have to write phases unless specified. All right, so if you're not sure what the phases are, don't write it unless specified. All right, but now I know that at room temperature, methane is a gas, oxygen is a gas, carbon dioxide is a gas, and water could be a liquid, but usually when we talk about combustion, I shouldn't have said at room temperature because when we combust things, it produces heat, so it's going to be above room temperature. So generally when we burn something, you don't see water coming out of it, you see gases coming out of it. Okay, so it probably is water vapor. But for phases of matter, we're going to talk about our solids, liquids, gases, and of course, we'll talk about aqueous solutions before long. Sometimes instead of solid, you'll see them put a CR, saying that it's crystalline. Okay, it's just emphasizing a type of solid. We've talked about crystalline solids already, so I don't use it, but once in a while it pops up. But again, phases don't have to be there. Also, sometimes putting in an equation is the amount of heat going in or out. In which case, instead of calling it a chemical equation, we call it a thermochemical equation. We're not ready for heat yet, okay? So I'm not going to bring in the thermochemical part yet, but understand that that is part of the process. All right, so you should have no issues with balancing equations at this point. You should have a basic understanding of the difference between a physical change and a chemical change, and the types of things that we need to look out for. That's it. Nice short video. Nice little introduction to Unit 4. And so go get the AP homework done. It is due today. I'm not giving you extra days anymore because some of you are just slackers and forget about it and forget about it and forget about it. So it's due today. Get it done. Bye.